Good afternoon, everyone. It is my pleasure to welcome you all to the 2021 Antonija Prelec Memorial Lecture. My name is Jamie Saragosi. I'm the head of the Health Sciences Library at Stony Brook University and chair of the Antonija Prelec Memorial Committee. Just a few housekeeping items. A reminder that today's lecture is being recorded. Attendee microphones have been muted. So please use the Q&A tool at any time, and we will pose those questions to our speaker at the end of the presentation. The code of conduct is being posted in the chat. There's closed captioning available at the bottom of your Zoom screen, and if you need any technical assistance, please feel free to directly message the hosts. I would like to take this opportunity to thank the Stony Brook Health Sciences librarians, Michael Wong, Jessica Coos, Greg Stevens, and Laurel Scheinfeld, as well as Interim Dean Shafiq Fazal, our Web Services Librarian Claire Payne, and Chair of the Library's Outreach Working Group, Stacy Harath, for their support and guidance while putting together this lecture. And I would also like to acknowledge the other members of the Prelec Memorial Committee who have been instrumental in planning today's event. Dr. Arthur Broman, Dr. Bruce Demple, Dr. Andrew Flesher, Eric Bremer, and Antonija Prelec's sons, Drs. Drosden and Marco Prelec. The Prelec Committee and this lectureship was formed in honor of Antonija Prelec to continue on her tradition of excellence in health sciences librarianship. Toni always made sure that her faculty and researchers had access to the latest and highest quality scientific evidence. I never had the opportunity to meet Antonija. However, I have had the pleasure of getting to know her through conversations with her family and colleagues over the years. And one thing that always comes through with resounding clarity is that while her professional focus was always on the information, she never lost track of the importance of the human element in her work. Every anecdote is similar. She would select the best titles, followed immediately by, and she hosted the greatest dinner parties. Or perhaps the most memorable for me was when her colleague said she was a brilliant librarian, but most importantly, working with her was always great fun. I hope you keep these values of Antonija in mind as we carry out our work today and in our daily work going forward. So without further ado, I will pass things along to my colleague, Dr. Andrew Flesher, professor in family, population, and preventive medicine, core faculty in the program in public health, and professor in English, who will introduce our 2021 Prelec Memorial Lecturer.
Thank you, Jamie, for the hard work you've done putting us in the position to enjoy this wonderful event today. As our colleague Bruce Demple noted over the weekend, it is nothing short of remarkable that today's featured speaker, who participated in a more than 8-hour grueling all Friday on an FDA panel charged with discussing the wisdom of offering boosters for COVID vaccines, would then be available for our audience at Stony Brook the following Monday. On this note, I am just delighted to have the honor of introducing Dr. Paul Offit, Director of the Vaccine Education Center and Professor of Pediatrics in the Division of Infectious Diseases at Children's Hospital in Philadelphia. He is the Maurice R. Hillman Professor of Vaccinology at the Perelman School of Medicine at the University of Pennsylvania. Dr. Offit has been in the news much, serving as the sane voice in the room, quelling widely harbored fears and stamping out misapprehensions and myths. A voice most recently heard in the critical health literacy task of clarifying the safety and efficacy of drugs and vaccines that exist in our arsenal in the fight against SARS-CoV-2. Dr. Offit is an internationally recognized expert in the fields of virology and immunology, and was a member of the Advisory Committee on Immunization Practices to the Centers for Disease Control and Prevention. He is a member of the Food and Drug Administration's Vaccines and Related Biological Products Advisory Committee and co-editor of the foremost vaccine text, Vaccines. Dr. Offit's numerous prestigious awards are too many to list, but here's a taste. He is the recipient of the J. Edmund Bradley Prize for Excellence in Pediatrics from the University of Maryland Medical School, the Young Investigator Award in Vaccine Development from the Infectious Diseases Society of America, and the 2013 Maxwell Finland Award for Scientific Achievement. Dr. Offit has published more than 150 papers in the area of rotavirus-specific immune responses and vaccine safety. He is also the co-inventor of the rotavirus vaccine Rototec, recommended for universal use in infants by the CDC. For this achievement, Dr. Offit received Luigi Mastroianni and William Osler Awards from the University of Pennsylvania School of Medicine. He also received the Charles Moreau Award from the National Foundation for Infectious Diseases and was honored by Bill and Melinda Gates during the launch of their foundation's Living Proof for Global Health. Dr. Offit is the author of several influential books which have received numerous accolades, one of which, Do You Believe in Magic? The Sense and Nonsense of Alternative Medicine, was for 5 years required reading in my own graduate student course, Contemporary Issues in Public Health. Dr. Offit has a book coming out tomorrow on the topic of risk-taking in medical decision-making. Medical care is supposed to occur in a way that at all times follows the principle of non-maleficence, and yet medicine itself could not advance without risking some harms. This is an interesting tension in medical ethics. Today, I imagine we can therefore expect to be presented with a message I have from time to time also heard mentioned by sagacious wedding officiants at the ceremonies over which they are presiding. The most momentous decisions we make in life are the ones about which there is incomplete information. This is almost axiomatic. To flourish is to make adult decisions. This in turn is to live with risk, which is why it is so critical to have a good understanding of what risk is. What risks are worth taking and how can we take them intelligently? We're going to learn something about this afternoon. And if the 15 minutes I had with Dr. Offit before this talk is any indication, we may learn something about the phone call he just had over the weekend with Dr. Fauci, where the debate occurred about whether or not boosters should occur for people under 65. Jamie has already done a marvelous job telling you about our gracious benefactors for this event, as well as Antonija Prelec herself, in whose name we have the privilege of inviting Dr. Offit virtually to our campus today. To Jamie's well-chosen words, I just want to add on a personal note, what a treat it is for me to sit on a committee where we have the resources to consider only the criterion of whom the very best person is to bring in front of our Stony Brook community, with no other imposed constraints. This is something that does not happen by itself, but because of an uncommon generosity. Over the past couple of years, I've gotten to know Drazen and Marco, Antonia's sons, as well as Drazen's wife, Danica. They are warm, engaging people, as committed to the issues like the ones about which we will be hearing today as they are magnanimous. My job does not get much better than during the rare privilege of introducing a speaker this good, and I wanted to thank them ever so much for this treat. Could we please offer a warm Stony Brook welcome to Dr. Paul Offit?
So thank you very much, Dr. Flesher. We're going to talk about the learning curve, I guess, is the way one acquires knowledge is invariably associated with a human price. We learn as we go. And I think a lot of what we do in medicine is basically how we deal with particular levels of uncertainty. So let's start with the issue of the day, which is COVID. So in January 2020, the journal Science published what was the sequence of SARS-CoV-2. So it was only, about a year and a half ago that we really first characterized that virus and sequenced the virus. Nonetheless, only 11 months later, we had done 2 large clinical trials using a technology, messenger RNA, that had never been used before and had remarkable results. So here, for example, are the Pfizer data. So the way the Pfizer vaccine worked, it was 30 micrograms of messenger RNA. The messenger RNA coded for the SARS-CoV-2 spike protein, given as 2 separate doses, 3 weeks apart. And what they found was that in this study of roughly 40,000 people, that the vaccine efficacy was about 95% in protection against symptomatic illness. Now, at the time when I was on the FDA's Vaccine Advisory Committee, we were told that if the vaccine was 50% effective with a lower bound of confidence interval of 30%, that we would approve this vaccine through emergency use authorization. And that the hope was, if everything worked exceptionally well, that we would have a vaccine that was 70% effective. But this vaccine was 95% effective as tested by Pfizer. And not only that, it was true for all age groups, for all comorbidities. Remarkable. And then the Moderna vaccine came around. The original review of the vaccine from Pfizer was December the 10th. 7 days later, we reviewed data from the Moderna vaccine. which was again a messenger RNA vaccine that coded for that provided the blueprint for the SARS-CoV-2 spike protein. This time, instead of giving 30 micrograms as a dose 3 weeks apart, it was 100 micrograms 4 weeks apart. But again, essentially an independent confirmation of incredible effectiveness in the 94, 95% range. Again, for all age groups and all comorbidities. Remarkable. Now, typically, the vaccine timeline is here. Normally what you do is you do a phase 1 trial, which involves 20 to 100 volunteers, where you do essentially a dose ranging study. You try different doses to see which one appears to consistently induce an immune response that you think is going to be protective, but you don't know that yet. Then for phase 2, you do usually several hundred volunteers, 300, 400, 500, at that dose or dosing interval, and to make sure you consistently get an immune response that you think is going to be protective, but again, you don't know that yet. And to make sure that it's at least safe in hundreds of people so that you can say you don't have a common serious adverse event. Then you do a phase 3 trial, which involves tens of thousands of people who either do or don't get the vaccine, which is now the definitive trial for safety and efficacy. Then you mass produce the vaccine and distribute it. And then you have in place now systems to see whether or not it continues to be safe. The length of time it typically takes to do this is on average about 15 years. For the rotavirus vaccine that I was fortunate enough to be part of at Children's Hospital Philadelphia, that was 26 years. And that's not that unusual. This was 11 months, and everyone continued to wait for the other shoe to drop. And also the names that were associated with this were not any more calming. So the name that was given during the Trump administration for this was Operation Warp Speed, because what the Trump administration did was they basically took the risk out of it for pharmaceutical companies. They said, look, we'll pay for the phase 3 trials. We'll pay which costs hundreds of millions of dollars. We'll pay to mass produce this vaccine while you're doing the phase 3 trial. In other words, if the vaccine was shown not to be safe or not to be effective, we'll just throw away millions of doses, our risk. So I think that's what sped things up. But this worried people. I mean, people thought that either timelines were being compressed or worse, that safety guidelines were being ignored. And so there was a lot of angst surrounding this vaccine when it came out. And you can see that here. I mean, initially, the vaccine confidence was low, but sort of got better as we developed more and more data. Okay, so confidence in vaccine safety and efficacy can be built on 4 20th century tragedies. This is all under the category of you learn as you go, or as historian Michael Harris said, that the history of drug regulation in America is built on tombstones. So we'll start with the first one, the St. Louis disaster, 1901. So diphtheria was a common killer and strangler of teenagers back in the early 1900s. It caused this thick leather-like membrane to block essentially the trachea, causing essentially suffocation. And the key advance here was in this man, Emil von Behring, who actually won the first Nobel Prize ever given, because what he did was he created diphtheria antitoxin. So in other words, that you inoculate animals with diphtheria, you then take their sera, and that sera then contains antitoxin. And he eventually also showed that you could take the diphtheria toxin, inactivate it, and serve as a toxoid. But this was the birth of diphtheria antitoxin, the early 1900s. In fact, it's the Iditarod race. The Iditarod race in Alaska is based on the fact that there was an outbreak in Nenema, Alaska of diphtheria. And so what they did was they flew diphtheria antitoxin into Nome, Alaska, and then the dog sleds brought it from Nome to Nenema, Alaska, and that became then the Iditarod race, and also became a very popular children's movie, cartoon, and called that was based on the lead dog. The lead dog of during this transport of antitoxin to Nenema, Alaska's name was Balto. If any of you are from New York, you would know that in Central Park there is a statue to Balto. Okay, so if you look at the right-hand portion, this is November 2nd, 1901 in the St. Louis Republic. 3 more deaths result from effects of infected antitoxin. So what happened is that there was an old horse that was used to make antitoxin. His name was Jim. He'd previously been a horse that would take the fire trucks to fires. He developed tetanus in September 1901. So the antisera that was generated then at around that time was discarded because he had tetanus. There was a lab worker named Henry Taylor who really fraudulently mixed the September antisera with antisera that had been detected a month earlier, which was safe. There were actually very sensitive safety tests to determine whether or not there were tetanus spores were contaminating. But in any case, because he mixed those two fraudulently, there were 13 children that died from tetanus as a result of getting tetanus antisera, as a result of getting diphtheria antisera. And that led to the first of what have now been several regulations. One is the Biologics Control Act of 1902. So on July 1st, 1902, President Theodore Roosevelt signed the Biologics Control Act, also known as the Virus Toxin Act, into law. Following inspections which could be unannounced, manufacturers of vaccines, sera, and antitoxins had to be licensed annually. Product labels had to clearly show the product name, license number, and expiration date, and a qualified science had to supervise every aspect of production. Punishments for violations were fines up to $500, which was a lot of money in the early 1900s, and a year in prison. Okay, so then we move along to, and again, there is no medical advance, whether it's blood transfusions, transplants, x-rays, anesthesia, chemotherapy, gene therapy, biologics like diphtheria antisera, antibiotics, or vaccines that have not been the subject of a massive, major tragedy. This was the next one, the elixir sulfanilamide disaster of 1937, which led to probably the most important federal regulation to date. So there were a number of companies that made sulfanilamide, which was hailed as the magic bullet. This was the first broad spectrum antibiotic that could treat a variety of infections, pneumonias, meningitis, et cetera. One company, well, I should take a step back. So sulfa drugs, a product of the German dye industry, were initially in tablet or powder form. These preparations were difficult for young children to swallow. So there was a company, Massengill Company of Bristol, Tennessee, that suspended the drug in diethylene glycol, which solubilized it and made it much easier to ingest. And so this was the only actually oral preparation of sulfanilamide that was on the market. So as a consequence, this headline appeared: drug fatality cause is traced to elixir. American Medical Association chemists say diethylene glycol was added to sulfanilamide, killed 13 initially. 10 months before marketing this product, researchers had already shown that a 3% solution of diethylene glycol caused kidney failure in rats. Elixir sulfanilamide contains 72%. So this was a completely avoidable problem. There were 240 gallons that were distributed of elixir sulfanilamide. 100 people died from kidney failure. 34 were children. If all 240 gallons had been consumed, 4,000 people would have died from that drug. Massengill's president said, quote, "My chemists and I deeply regret the fatal results, but there was no error in the manufacture of the product. I do not feel there was any responsibility on our part." Technically, he was right. There was no error in the manufacturing of the product. No law had been broken. The company had complied with what were weak federal regulations. The chief chemist at Massengill, however, Thomas Watson, killed himself. And this led to the Food, Drug, and Cosmetics Act of 1938. It was signed into law by President Franklin Delano Roosevelt. Drugs had to list all products on the label and prove safety before licensure by the Food and Drug Administration, which actually just came into being in 1927. And the FDA also had to inspect and license manufacturing plants every 2 years. Manufacturers still didn't have to prove that their products were effective. It took another tragedy to get there, and that was this tragedy, the thalidomide disaster of 1957. So on October 1st, 1957, a German company called Chemie Grunenthal distributed thalidomide. It was advertised as a sedative. It was claimed to be safe even for pregnant women, even though it was tested in pregnant women. It damaged more than 24,000 fetuses, causing phocomelia, where your hands or feet are directly attached to your body. Half of these children died before birth. Although it was never licensed in the United States, it did lead to the next major piece of federal legislation, which was the Kefauver-Harris Amendment of the Food, Drug, and Cosmetic Act of 1961. Drugs had to be now proven to be effective before licensure, even though thalidomide was a safety issue. Previously licensed drugs could be withdrawn if found to be unsafe after licensure, and prescription drugs had to include a summary of side effects. This is the first time really that you had to prove that your product was effective and had to list any side effects on labels. Manufacturers had to obtain consent from patients before testing experimental drugs. Product labels had to include exact quantities of all ingredients. Manufacturers had to adhere to a code of good manufacturing practices. These three regulations put an end to America's Wild West medical show, which was basically patent medicines, with the exception of dietary supplements which were reborn and basically freed from these amendments and laws with the Dietary Supplement and Health Education Act, but that's another story for another day. Okay, so now, people are feeling more comfortable. We have these laws in place which will protect us, but nonetheless, tragedies occur, which led to, I think, what was the greatest biological tragedy in this country's history, which was the Cutter incident in 1955. So in 1952, 58,000 cases of polio were reported in the United States. 65% of cases occurred in children between 5 and 9 years of age. 90% of children and 100% of adults living with someone with polio became. This was, I'm a child of the 50s. I can tell you that my parents were scared to death of this virus. I was born in 1951, so 4 years before the polio vaccine. I was not allowed to swim in a public swimming pool. Me and my two cousins had to swim in this little plastic pool in the back. Only about 1 out of every 100 to 1 out of every 200 people who were infected with polio were paralyzed by it. So like SARS-CoV-2, most of the transmission of the virus was asymptomatic. But this was a devastating disease for many reasons. One, because it affected children, young children, primarily less than 9 years of age. Two, because it affected muscles of respiration. So this is just a picture from California of children in iron lungs. And I think what was probably most devastating is it really never affected your brain. It affected the spinal cord. So you were perfectly aware of everything that was happening to you. And there are people that lived in iron lungs for decades. I mean, I actually had an operation on my right foot that was a failed operation to fix a club foot, an operation that really wasn't perfected for another 40 years. And so I was in a hospital called Kernan's Hospital for Crippled Children. That was back in the days when you could use words like crippled and feeble-minded in the names of hospitals. And I was in a polio ward. I was there for about 6 weeks, and this is what I saw. I saw children in traction, children in iron lungs, and I think it's probably the reason I went into pediatrics and ultimately pediatric infectious diseases was just the scarring that comes with being in a hospital like that for 6 weeks and seeing these children who are so vulnerable and alone. And this is in the days before they had therapy pets or iPads or for the most part, visiting hours. There was one visiting hour a week on Sundays from 2 to 3. And that was it. And my bed was right next to a window that overlooked the front door of the hospital. I just remember staring out of that window, looking at the front door, waiting for my parents to come and save me. So the person who stepped up here was Jonas Salk. And what he did was he took poliovirus, grew it up in cell culture, purified it, and then killed it with formaldehyde. And then that led to a test of his vaccine that was headed by Thomas Francis at the University of Michigan. So Salk had been influenced by Francis because he had trained in Thomas Francis's lab. Thomas Francis had propagated influenza virus in eggs, harvested the allantoic fluid, and inactivated the virus with formaldehyde. That's where Salk really became aware of how he was going to make his vaccine. The key breakthrough here, and the Nobel Prize winning breakthrough, was these three researchers, John Enders on the right, Fred Robbins in the middle, Tom Weller on the left. What they figured out how to do was to grow poliovirus in non-neural cells. Because if you grew poliovirus in neural cells, which was done actually in the 1920s and 30s, and then you inoculated people with that vaccine, you could induce essentially immune response against your own myelin basic protein, which would basically cause a paralysis, coma, and occasionally death. It was just, we couldn't use neural cells. We had the same problem with rabies vaccines, but this was the breakthrough. So what Weller and Robbins and Enders did was they adapted poliovirus to growth in cell culture. This allowed polio to grow in large quantities, especially and obviated the need for monkey spinal cords as a source of virus, for which they won the Nobel Prize in 1954. And so what proceeded then was a trial that broke Jonas Salk's heart. What Salk had done was he had taken poliovirus, grown it up in monkey kidney cells, as he had been educated to do by Enders, Weller, and Robbins' work, purified it, inactivated it with formaldehyde, as he had been educated to do that basically by Thomas Francis's work. And then he gave that to 700 children in and around the Pittsburgh area. He found that his vaccine was safe. He found that his vaccine induced an immune response that was highly immunogenic, and he reasoned that this was it. Eureka, I've got it. This is a polio vaccine. Nonetheless, the March of Dimes wanted to do a trial to prove that it worked. This is the way we all looked in the 1950s. And so the way that the trial was done was, so 3 doses of the vaccine were given to 420,000 children. The vaccine was made by 2 veteran vaccine makers, Eli Lilly and Park Davis. 200,000 children were inoculated with placebo. 1.2 million children served as observed, uninoculated controls. This was the largest test of a medical product ever performed. And the efficacy was about 65% against type 1, 100% against type 2, 96% against type 3. The reason, interestingly, that it was poor against type 1 is that although Salk didn't include a preservative in his trials, the March of Dimes insisted that for this trial that a preservative be included. That preservative was ethyl mercury, which is thimerosal, which was deleterious against poliovirus. It affected the surface proteins and made for a lesser response. So let me take a step back. And so Thomas Francis actually was in charge of this trial. And he declared, when the trial was done and the vaccine was found to be effective, that the vaccine was, quote unquote, safe, potent, and effective. He declared that in Rackham Hall at the University of Michigan, and those 3 words, safe, potent, and effective, appeared on every headline in this country. I mean, church bells rang out, synagogues held special prayer services. Department stores stopped while this announcement was made. It was carried over the Voice of America to Europe. It was a seminal moment in this country, and it occurred in April of 1955. What bothers me the most about this story, actually, and I talk about this a little bit in a book called You Bet Your Life, which comes out tomorrow, was how did he know it was effective? He knew it was effective because 16 children died in that study from polio, all in the placebo group. He knew it was effective because 36 children were paralyzed in that study, 34 in the placebo group. This is what Jonas Salk couldn't conscience. He couldn't conscience giving salt water to children in the 1st and 2nd grade heading into the summer in the mid-1950s, knowing that polio was a scourge, knowing that some of these children were going to suffer or be killed by that virus. He couldn't conscience it. And it broke his heart, this trial, in many ways. Even though he was a hero, a national hero, remains probably one of the better known names in science, this trial broke his heart. And again, it brings up the issue of what price knowledge? What price are we willing to pay for knowledge, human price? So in any case, 5 companies stepped forward to make this vaccine. The first 2 that made it for the trial, Eli Lilly and Park Davis, as well as 3 smaller companies, Wyeth, Pittman Moore, and Cutter Laboratories. Cutter was the smallest in Berkeley, California. So a few weeks after the vaccine was released, this headline appeared in the New York Times. 1 firm's vaccine barred, 6 polio cases are studied. So the Epidemic Intelligence Service, which was created actually by Alexander Langmuir at the Centers for Disease Control and Prevention, sort of went about trying to figure out what happened, because it was April. It was a little early for polio. Polio was more of a summer phenomenon. And also these cases occurred in the paralysis occurred in the arm that was inoculated and occurred temporally associated with getting the vaccine. So what Neil Nathanson, who worked at the Epidemic Intelligence Service at the time, did was he looked at the 8 lots that were made by Cutter and found that in 2 of them, the incidence of paralysis was much greater than the background rate and much greater than was seen in the other 6 lots, these 2 so-called high-risk lots. When the dust settled on this, the Cutter incident, 120,000 children were inoculated essentially with live, fully virulent poliovirus. 100,000 family and community contacts were also infected. This was a man-made polio epidemic because we had failed the Cutter Laboratories had failed to fully inactivate the virus that was contained in that vaccine. At least 70,000 people developed abortive polio, which is a short-lived paralysis. 164 people were permanently paralyzed and 10 people were killed. And as I said, I think this was the worst biological disaster in our country's history. The problem was filtration. Salk had used the CITES filter, which was a very slow way of filtering the virus cell preparation. So in other words, you take cells, grow them up in cell culture, you infect the cells with virus, and then the virus destroys the cell, and then you want to separate the virus from the cells. And this was an efficient way of doing it. The purification was excellent. The LU8 was usually referred to as gin pure, meaning you couldn't see a speck in there. But that's not the way Qatar did it. Qatar used a different filtration system. So this is actually an actual picture from Qatar Laboratories. And what happened was they didn't effectively separate the vaccine the virus from the cell. So there was a lot of cell debris, and the virus essentially then hid in the cells. And then when you added formaldehyde, it didn't effectively penetrate into the cells and kill the virus. So this straight line that Jonas Salk had created, where if you use formaldehyde, you can get a millionfold reduction over 3 days. And he reasoned that if you give another 3 days of formaldehyde, it's another millionfold, then another millionfold reduction. It didn't work out that way. You weren't able to effectively inactivate the virus if you couldn't purify the cells away from the virus. So this resulted in the Division of Biologic Standards in 1955, which still exists, and it was the birth really of vaccine regulation. On July 15th, 1955, 3 months after the Qatar tragedy, the government created this Division of Biologic Standards. By 1956, the number of professionals regulating vaccines increased from 10 to 150. Today it's thousands, and regulators are now actively involved in studying the vaccines they supervise. That wasn't true then. Then, sort of regulation was much more haphazard. People that did the regulation, often they weren't involved in that particular virus at all. A series of consecutive lots of vaccine equaling potency, safety, and efficacy is now required of all vaccines, and the term consistency lots, which is still used, by the way, is born of the Qatar incident. And so we were able to, as we gradually were able to vaccinate people, we gradually decreased the incidence of paralysis. Interestingly, think about the Qatar incident happening today. It didn't really affect the uptake of the vaccine. People were still willing to get the vaccine, even knowing there had been this massive tragedy associated with one of the products. And so the polio vaccine introduced in 1955, and there were at that time about 29,000 cases per year. There was a dramatic decrease then, and ultimately an elimination of wild-type polio virus from this country by the late 1970s. So, and what was also created were essentially a number of vaccine safety post-approval mechanisms. Like in the late 1980s, the Vaccine Adverse Events Reporting System, which is co-directed by the CDC and the Food and Drug Administration, which is at best a hypothesis-generating mechanism. You can detect safety signals very quickly, but what you can't do is you can't assign causality. You can only do that if you have a control group, and this Vaccine Adverse Events Reporting System doesn't allow for that. And I'll give you an example of where the Vaccine Adverse Events Reporting System worked well. It was a rotavirus vaccine that was introduced in the late 1990s called RotaShield. So there was a vaccine that was introduced in 1998. About 10 months after that vaccine was released, this headline appeared in Morbidity and Mortality Weekly Report: Intussusception among recipients of rotavirus vaccine, United States 1998 to 1999. Intussusception occurs when your small intestine sort of telescopes into itself, gets stuck, and that can lead to a medical disaster, which is that you can get then the ingress of bacteria into your bloodstream, which can cause sepsis and death, or you can get massive bleeding, which can cause death. So intussusception is a big deal. There were 15 cases of intussusception following RotaShield that were reported to VAERS. 13 of the 15 occurred after the first dose. 11 of 13 occurred within 7 days of the vaccine administration. 8 of 13 cases occurred in children much younger than you would typically see intussusception, because usually intussusception is a disease at the 5 to 9 month old, and here you were seeing it in 2 to 3 month olds within a week of getting the vaccine. So the Vaccine Safety Data Link was also created. This is all as a consequence in many ways of the tragedies that preceded this, which consists of 9 participating integrated healthcare organizations, include data in over 12 million per people. And this enables you to very quickly see when a vaccine rolls out whether or not there are more side effects in the vaccinated than unvaccinated group. And this applies right now to SARS-CoV-2, which we'll get to. So this proved that intussusception was a consequence of the RotaShield vaccine, and for that reason it was taken off the market about 10 months after it went onto the market. which is seen here. And there remain safety issues. The oral polio vaccine developed by Albert Sabin is also a rare cause of polio. It occurs in about 1.4 million doses, rare but real. Gelatin allergies and egg allergies account for about 1 per million cases of severe allergic reactions in vaccines. The measles vaccine causes a lowering of the platelet, which is transient but is real. The influenza vaccine is a rare cause of Guillain-Barré syndrome, which is a neurological problem, occurs in about 1 per million people. The Pandemrix vaccine, which was not used in this country, but it was a squalene adjuvanted flu vaccine used in Europe, was a rare cause of narcolepsy, which is a permanent disorder of wakefulness. And the yellow fever vaccine causes something called viscerotropic disease, which is a very, very fancy way of saying yellow fever. The yellow fever vaccine could itself cause yellow fever, again, very rare but real. And all of these have been picked up because of safety systems like the Vaccine Safety Data Link. And so, which brings us to SARS-CoV-2. I mean, we now know that the Johnson & Johnson vaccine was a rare cause of what's now called thrombosis and thrombocytopenia syndrome. It occurs extremely rarely. It's about 1 per 500,000 cases, but it's real. Similarly, myocarditis is a consequence of the mRNA vaccines. Again, rare but real, primarily occurs after dose 2, primarily in males. And occurs about 1 in 20,000 vaccine recipients. But to see where we are now is that we now have systems in place that enable us to determine extremely rare side effects associated with vaccination. And then you have this VSafe system, which is also created by the CDC, which enabled us to look at tens of thousands of women that were pregnant and got mRNA vaccines very soon after these vaccines were released, and showed importantly that there were, not seen on this slide, but on this slide, that there were no problems with either the maternal outcome or fetal outcome, neonatal outcome. So these vaccines are safe in pregnancy, again, because of systems that were put in place because of these tragedies. So I think this is my last slide. Historically, medical advances have come at a human cost. We always think we don't want to pay that human cost, but we always pay a human cost. Largely because of that cost, systems have been put in place to ensure that vaccines are tested in large trials, pre-licensure that prove safety and efficacy, and held to a very high standard of manufacture, and observed post-approval to make sure that they do not cause rare adverse outcomes. So that is all I have. Thank you for your attention. Let me close this. And then here we are. Here I am.
Thank you so much, Dr. Offit. I can assure you if we were in a lecture hall right now, there'd be a round of applause for you. So I will do so on behalf of our group. And I'd like to get us started with some questions. I do know that we have some questions from our audience. So please feel free to continue adding questions to the Q&A feature on your Zoom control panel. But I will get us started actually with a question from our founding member of the Antonija Prelec Memorial Committee, which is Dr. Arthur Grolman. And he has said that while Dr. Anthony Fauci is a reliable source of information regarding COVID-19, he called attention to the urgent need for oral antiviral drugs as opposed to antibodies to complement the vaccine initiatives. The new antiviral program for pandemics provides ample resources to cover costs of research and development for antivirals. So his question is, could a mechanism other than the current FDA process, which requires many years, be devised to make such drugs available in a shorter time frame, such as 2 years, while preserving both safety and...
I think that's happened to some extent. I think the emergency use authorization mechanism in the midst of a pandemic has allowed for much quicker response. I mean, typically the length of time that it took to get, for example, a vaccine licensed was about 10 months. Now with the post-approval process, I mean, remdesivir that was made available fairly quickly, and that first trial, the 1,000-person NIH trial, was done fairly quickly. I think that drug is overrated. I mean, I think we're now learning that it's not what we hoped it would be, primarily because by the time people are pretty seriously ill, its viral replication is not an important part of pathogenesis anymore. It's really the immune response. So it's the anti-immune drugs like this JAK2 inhibitor that just was approved, and dexamethasone. I mean, those are really the drugs that seem to make the most difference for seriously ill people. And obviously, the monoclonals are incredibly valuable, but they have to be given early, just like remdesivir would have to be given very early, sort of a pre-hospital phenomenon. But I do think the EUA mechanism has made for quicker use, and you would argue in some ways it's been abused. I mean, I think that under the Trump administration, the pushing for hydroxychloroquine, the pushing for convalescent plasma was not to our benefit.
Thank you.
And look at vaccines. I mean, this vaccine was made in 11 months. That's the winner. That's the all-time winner. The previous winner was mumps, which was the virus was isolated in 1963. It became a product in 1967. 4 years was the previous winner, and the regulations were much more lax then than now. So I think the EUA mechanism does allow for this to be quick. See, here's the part I don't understand. I mean, this vaccine, which is honestly, I think in my lifetime, was probably one of the greatest medical accomplishments I've ever witnessed. It was a product of the Trump administration. This was Operation Warp Speed was the Trump administration, but Donald Trump has been sort of slow to embrace it. I don't know why. I mean, I think it's because at his heart he's a very modest man who doesn't like to put his name on things, but I could be wrong about that.
We'll leave that one there and move on to the next question.
Never talk about politics. And I can give you my email so you can send me the hate mail. Okay, it's offit@chop.edu.
Yeah, I don't think you'll get much. We do have a question from Dr. Andrew Flesher, who you've all met earlier in the presentation, related to the panel that you sat on Friday, the FDA advisory panel. Could you go into a little bit more detail about the risk and benefit of the boosters? So what were some of the reasons why you were apprehensive about rolling out booster shots to the general population at this time?
Right. No, it's a great question. So the question is, what's the goal of the vaccine, as expressed very well by Rochelle Walensky and Dr. Fauci and others, has always been protect against serious illness, meaning keep people out of the hospital, keep them out of the ICU, keep them out of the morgue. And so if you look at the roughly 5 studies that have been done recently in the United States that were reported just in the last couple of weeks in MMWR, these vaccines do exactly that. Whether it's the Pfizer vaccine or the Moderna vaccine, because that's what we're talking about, is boosting the mRNA vaccines. Whether it's the Pfizer vaccine or a Moderna vaccine, independent of age, independent of the presence of Delta, those vaccines are in the high 80 to low 90% protective against serious illness. The outlier is a study in Israel, which shows that there is an erosion in protection against serious disease in people over 60 who have received 2 doses of an mRNA vaccine. And Dr. Fauci and Dr. David Kessler in the Biden administration have become convinced that that's what's about to happen to us. But I think why that's not about to happen to us is the immunological effector function that's associated with protection against serious disease. It's not neutralizing antibodies in the sera. What it is it's memory cells, memory B cells, memory T helper cells, which are generally high-titered and long-lived. I mean, if you look at work by John Weary at University of Pennsylvania or Shane Crotty at La Jolla, they show that 2 doses of mRNA vaccine induce high frequencies of memory B cells that would account for what we're seeing, which is continued protection against serious illness. Now, what happens over time for this kind of vaccine, it's true the rotavirus vaccine too, is that over time, serum neutralizing antibodies will decline. And with that, there'll be an erosion in protection against asymptomatic infection, mildly symptomatic infection, and low moderately symptomatic infection. And with that, an increase in contagiousness, right? Because although you're somewhat less contagious if you've been vaccinated and then have a mild infection, you still are contagious. So the thinking there is, okay, let's get on top of contagiousness. Let's change the R naught by having a booster dose, which will clearly increases, as Pfizer shown, about a 3-fold increase in neutralizing antibodies, which will then presumably decrease contagiousness and therefore help us get on top of this pandemic. What I would have liked to have happened, and we sort of charged, I think, the 2 people that are on the committee from the CDC with this, is model this. Is it true? Is it true that if we give a 3rd dose, because we're not now about to give a lot of 3rd doses to people in this country, is it true that will in any way significantly alter the arc of this pandemic? Because to me, and I think that nobody disagrees with this, if you really want to change the arc of this pandemic, vaccinate the unvaccinated. I mean, we are about to see that this vaccine is going to be, I suspect, by the end of the week, the CDC is going to say, give a third dose to people over 65. Give a third dose to people who have risk factors that put them at high risk for serious disease. Do that. And possibly give the vaccine to people who work in situations where they're likely to acquire the virus, i.e. hospital settings. But I can tell you that in our hospital, at the hospital of the University of Pennsylvania, when we see people with high risk who come in, who are then admitted to the hospital, go to the ICU, put on, on ventilators, it's not because they didn't get their third dose. It's because they never got either of the first two doses. I mean, that's what we're seeing. And I just wonder whether this is going to have much of an effect. But I can tell you the minute that President Biden stood up and said, we're going to give a third dose, we're going to give it 8 months after the second dose, although I think the recommendation is going to be 6 months. Everybody in the public can get it. If my emails are any indication, people are storming the gates to get that third dose. Which will, I think, definitely enhance protection and increase their neutralizing antibodies for a year or two, but it's going to come back down again. So I just don't quite understand the thinking here. The third dose recommendation has been being sold as this is a 3-dose vaccine, just like the hepatitis B vaccine, just like the polio vaccine. It's a 3-dose vaccine. But I don't, and the reason it's given is that if you look at those products, you need about 4 to 6 months between doses in order to get adequate levels of memory B cells. But it looks like 2 doses of messenger RNA do that, because this is not an inactivated vaccine. I mean, in many ways, it functions like a live attenuated viral vaccine, because you're giving the gene that then goes into the cytoplasm, that then you get the protein that's translated, much as the way, which is true for every live attenuated viral vaccine. The only difference is that here it's just one protein, one of the 4 proteins that are part of the virus, as distinct from all the proteins that then get assembled into a whole virus particle that leave. But I think it's more like actually a live attenuated viral vaccine, which is why I think you get such amazing memory responses. So I don't know. I don't get this. I think that our committee was right to vote this down 16-2 initially, and then right to say let's do it for those over 65. And I think it certainly won't hurt those who are at greater risk. I think it may help them somewhat, and we'll learn over time. I mean, I hope I'm wrong. I hope that what we find is that with this third dose recommendation, we get on top of this pandemic much more quickly than we would have otherwise. But I just think what the problem is, we got 25 to 30% of the population, we got 60 to 65 million people who are saying, no thanks, I don't want a vaccine. I am just going to allow this virus, I'm going to be fertile ground for this virus to continue to spread, continue to mutate, continue to cause harm, continue to create variants that may become more and more resistant to vaccine-induced immunity, and what are you going to do about it? And we're trying to do something about it. I think that's where all the mandates are coming from. But you're seeing, I think, one of the flaws in this country is that, we're a country founded on individual rights and freedoms, and somehow we think that's also the freedom to catch and transmit a potentially fatal infection, which I would argue it's not. But that's where we are.
We do have follow-up questions regarding the boosters versus kind of reworking the vaccines themselves for the variants. Do you have any opinions on kind of reworking the vaccines to be more effective against the variants? And if that is a viable option, does that have to go through the approval process from step 1 all the way through?
No, that's a great question. I mean, if we're going to give a third dose, why not use the mRNA that codes for the Delta variant spike protein? Wouldn't that make more sense? Wouldn't that broaden the immune response? Why rush to do this, using the SARS-CoV-2 spike protein from the ancestral strain, the strain that first came out of Wuhan? Why do it that way? It's a good question. And what's the rush anyway? I mean, this was rushed. I think that don't get me wrong, I think that both the Trump and Biden administration regarding this vaccine have done a yeoman's job. I do think that the Biden administration has to be congratulated for figuring out how to mass produce, mass distribute, mass administer this vaccine. It's free. They've done their best to get good information out there to try and decrease bad information. It's all good. I think that we all desperately want the same thing, which is to end this pandemic. But I think by giving it a date, when President Biden said, September 20th, we're going to have a vaccine available for the general public, that rushed things. I mean, there was a New England Journal of Medicine paper that just went through peer review like the day before we met last Friday. Well, why couldn't we wait a week or two just to see, so we could all more carefully review all these data? I just don't like that this was rushed, and it was rushed because President Biden put a date on it. And I think by doing that, and not initially saying we need to go through the FDA, we need to go through the CDC, and we'll see what happens. I think he marginalized those two institutions, and you can't do that.
I have a question in the spirit of this being an event in honor of a librarian. Our questions or you mentioned how the information is being transmitted, and in your lecture, you showed a slide of the New York Times headline. Now with the 24-hour news cycle and information coming from unconventional platforms, you mentioned also peer review. We know that peer review has become kind of a rapid review in many cases in terms of the COVID literature. So how do you feel the researchers themselves now are responsible, if at all, for the information and how it's being disseminated? Or do you feel this is still two separate roles, one responsible for research and the information happens as it happens?
Oh, that's such a good question. I think it's a new time, right? I mean, we're in the midst of a pandemic. There was a lot of money being spent trying to understand this virus, trying to understand the strengths and weaknesses of this vaccine, trying to create antivirals, both oral or IV, trying to make the right kind of monoclonal antibody cocktail, et cetera, et cetera. So sequencing the virus, looking constantly to see, what variants are being produced, whether they're variants of concern, variants of interest, et cetera. Before this, there were about 4,000 papers published a day in the scientific and medical literature. I think this doubled it. I think we're like another 4,000. And what you're seeing for the first time is you're seeing papers that are published that will reference or put in their references section a paper that has not yet been peer reviewed. And I'll take it a step further. And you see occasionally people, because there are some very responsible labs that will let you know data on Twitter, very quickly, so you can see, and that's been referenced. I've seen Twitter references on papers. I mean, the next thing it's going to be like something you heard on the bus on the way to work. Definitely the bar has gone down. I will disagree with one characterization that you said, the 24-hour news cycle. So here's my theory about that. I was on CNN this morning. I was on MSNBC this afternoon. I'll be in theory on CNN again tonight. So there is not a 24-hour news cycle. There's a 2-hour news cycle that's repeated 12 times. This is my theory about this.
This is the inside information that you're giving us here. That's fantastic. Thank you. And as librarians, I know we're still trying to teach the correct principles of citation, but I don't think we're quite ready to tell people how to cite Twitter in their scientific papers just yet. Okay, another question for you in terms of, we'll go back to vaccine efficacy. Will boosters be needed for the Johnson & Johnson vaccine as well, as it was a 1 versus a 2 dose?
Right. So Johnson & Johnson vaccine. So the mRNA vaccine, really, it took 2 doses to get excellent high frequencies of memory B cells. That happened after 1 dose of the Johnson & Johnson vaccine. That's why it was a 1-dose vaccine. Now they did both in their preclinical studies and their phase 1 studies. They clearly had a booster response with the 2nd dose, about 2.5 to 3-fold increase in neutralizing titers. The question is, did that also correlate with better clinical outcome? So they have done a 2-dose trial, and my understanding is they finished that 2-dose trial. So I don't know why the FDA Vaccine Advisory Committee hasn't seen those data yet. Maybe I don't know why. I'm not going to speculate as to why, but it would be helpful to see it. I know there are cities like San Francisco that are recommending, the public health people in San Francisco are recommending, give a dose of mRNA vaccine if you've already gotten a dose of J&J vaccine, for which there aren't a lot of data. I mean, I think that I am going to make this prediction. The CDC is going to be considering the issue of booster dosing by the end of this week. And so they're going to have a recommendation. I hope that they have a recommendation not only for people who've received 2 doses of the mRNA vaccine, but also who've received 1 dose of J&J vaccine, because that is certainly a common question.
Thank you. Another question, and I think this is something that people will probably appreciate hearing your opinion on, is the antibody testing. And where do you feel that falls in people's decision-making processes, or how reliable is the information that we're receiving from these antibody tests?
Yeah, first of all, it has to be the right kind of antibody, which is neutralizing antibodies, not binding antibodies. Secondly, I think we're driving ourselves crazy with this. I think you can still have relatively low neutralizing antibody titers, but because you have immunological memory, you're still going to be protected against serious illness. So my recommendation on getting titers, assuming you're immune competent, is not to get them. I think if you're immune compromised and you're trying to see whether a 2nd dose or 3rd dose is of value, I think there it's worth worth doing, but otherwise I wouldn't do it. Also, one other thing before we end, I saw Eric Mackow had a little thing that came up in the chat, and Eric and I trained together at Stanford 100 years ago, I think today. So just want to give him a shout out, assuming he's still in the program. Hey, Eric.
That's great. You have another former colleague here, Susmita Patti. She had given you a shout out in the chat as well. And we are right at the top of the hour, and considering that you have to log on for your 2-hour news cycle in just a little bit, I think we'll stop here. I apologize. I know there were questions coming in that we just didn't have enough time to get to, but I'll encourage everyone to check out Dr. Offit's book that comes out tomorrow, or look for him on some of these news channels to hear more information about his opinion on these boosters. And we thank you for your time and for being so gracious with your time with us here at Stony Brook. So thank you for being our 2021 Prelec Memorial Lecturer. It has been an absolute pleasure. So thank you everyone for attending.
Thank you.